Good morning all, Siddhu Patil here. In today's session we are going to continue about the software engineering. This is the third video lecture. Welcome to this. In today's session we are going to discuss about the software engineering ethics. Okay, so in general we know that ethics are important parts of life. To become a good human being, we should follow some of the ethics, some of the principles in our day-to-day life. So what will be the software engineering ethics? So what are the common ethics which in day-to-day life we people are following? So the same thing we have to implement in our engineering life also, in general life also, or in a social life also. So software engineering involves wider responsibilities than simply the application of a technical skills. Okay, so if you are good at a technical skills, but along with that you should be follow some of the rules and regulations of the software engineering. Software engineers must have be honest and ethical, responsible way if they are respected as a professional. So you are good at someone coding or something, you have the good technical skills, so you should be very honest with your profession, and you should be behave like a true gentleman. Okay, next, ethical behaviors is more than a simply upholding the laws, but involves the following set of principles that are normally correct. Okay, so along with that good technical skills, you should follow these principles, or what we are going to call ethics: confidentiality and the competence. What is confidentiality? If suppose I am giving the project to you people, okay, and while giving the project I am giving my confidential data, okay, for example bank details and etc etc, all the things. So you should be very proper with the particular client. Okay, engineers should normally respect the confidentiality of their employees or clients, irrespective of whether or not a formal confidentiality agreement has been signed. Okay, right now I have all the details of you people. That is nothing but your mail ID, your phone numbers are there. If I get it is possible for me to get the bank details of you people also. I should not share such a details with any other the people. So this is nothing but the confidentiality. You should people trust to me, and I have to trust in you. Employees should trust their clients, and clients should trust their companies, and as well as the stakeholders. Next comes the competence. Engineers should not be misrepresent their level of competence. They should not knowingly accept work which is out with their competence. That is nothing but the, if you are signed one of the agreement, that time you have to you have to be follow with that agreement itself. Right now I am a lecturer, so what is the competence is that I should not take private tuitions and all the things. So these are the one of the issues you should follow with being a good software engineer. One is confidentiality and another one is competence. Next comes to the intellectual property rights. So intellectual property right, sorry for the pronunciation, property rights. So these are nothing but you should follow some of the rules and regulations while taking the one of the software. Right now I'm using this OBS software. This is a free open source software, but if it is a paid version, that time I have to follow the some of the rules and regulations. That is nothing but the patent and copyright. You should not take someone's already predefined logo, and you should say that this logo is designed by me. Okay, or if you are originally the music is composed by one of the musician, and next you think that you are just giving your own language, and you should not say that this is originally taken by me. And to be frank, this whatever the what I am using this PPT, I put my name in the header file, that is in the footer. Okay, so few of the slides are copied from this summary village. So when it comes to the legal things, that time I should display their names and all the things. Next, computer misuse. Software engineers should not use their technical skill to misuse their others people's computer. If right now we have the 60 systems, and we are password protected. If you are good at technical skills and you are able to hack those systems, but and you should play the games, you should you are misusing those data. So these are not the ethical things. So you should be very confidential, You should competence, intellectual property rights you have to follow. Next, you should not use the computer for your personal use, or someone's personal computer you should not use for your personal work. So these are the important aspects of the what we are going to call ethics of a software engineering. Next comes the one of the ethical principles. This is another one of the important question for your exam point of view. Okay, public software engineers shall act as a consistently with the public interest, client and employer, product, judgment, management, profession, colleagues, and self. So these are the ethical principles. You constantly are working for the public interest, that you have to be keep in mind. Next, you should respect your client and you should respect the employer. Next, whatever the product you people are designing or you people are thinking to design, it should meet the customer satisfaction. Next comes the judgment. A software engineer shall maintain the integrity and independence in their professional judgment. So you should take the proper judgmental decisions. Next comes the management. Software engineering managers and leaders shall subscribe to promote the ethical approach to the management of a software development and maintenance. That is nothing but the man who is at the good leading positions. They have to manage those all the stuffs and all the things. And you should be very prompt with your profession. Next, you should respect your colleagues. You should respect your friends. You should respect your team. You should have the faith in each and everyone. And next, most important is self-confidence. Software engineers shall be participate in lifelong learning regarding the practice of their profession and shall promote the ethical approach to the practice of the professional. The self-confidence is very, very important. Next comes the few of the case studies. Total 4 case studies are mentioned in syllabus. I am explaining 2, and in the interaction session or the 2 will be homework for you people. One is personal insulin pump, and next is a mental health case, patient management system. Next one is Wilderness weather station, that is weather prediction, and next is a digital learning environment. So one by one we are going to discuss. First we are going to discuss the insulin pump control. So I hope many of you people have visited hospital for some of the other reasons, or you should know the working of system or working of the entire things in a ICU, intensive care unit. So this all thing about the controlling the blood sugar level. Though a few of the people have suffering from the diabetes, and to maintain the diabetes they are taking external insulin. So for this the engineers have created one of the insulin pump control system. How it is going to work it? So before going to this entire theoretical part, I like to explain the few concepts regarding about the insulin pump. So if suppose for timing, if I am suffering for the diabetes, so daily my blood sugar level we have to measure it, and based upon the requirement, how much ml of insulin I have to take from external, that have to be calculated, and according to the dosage will be given. So this is a manual process. But when it comes to the actual engineering process, the combination of embedded system, combination of software and hardware. So here the system they have designed here. So what is that? The main thing is controller and pump. Okay, so the sensors are attached to the patient, or attached to the patient. So these sensors are sending the signals or sending the information to the controller. This person or this patient number 1, it required the 4 ml of insulin at 10 o'clock after the food. So what the controller is going to do? Controller is going to set the first thing is going to set the alarm after 10 o'clock. The 4 ml of insulin have to be injected to the patient. So next the alarm will be set. Here the display 1 and display 2 are there for the external or the one who is going to manage the things. The display is going to check that. Okay, next is a needle assembly, and next is a pump. So what is going to do? Once the sensors are going to send the signals to the controller is sending the sensor information to the pump. Okay, and the pump is going to inject the 4 ml of insulin with the needle assembly. Okay, so this is the simple architecture, and it is connected with the power supply, and insulin reservoir. So each and everything in the insulin reservoir, the insulin is there. How much insulin we required? For example, for timing we required 4 ml. That 4 ml have been taken, and the needle assembly is going to pump into the body. So this is the blueprint or architecture of a insulin pump hardware architecture. Next, how exactly it is going to be done, or it is going to be activated. So first thing is that blood sugar, some of the sensors are there, the blood sensors are there, that is going to measure the take the information from my body or patient body. Next, it is going to analyze the sensors reading, how much it is the minimum value, how much is the maximum value. And next, it is going to maintain the blood sugar level, that is it is going to check that how much it is the patient is required for timing 4 ml. Next, so what it is going to do, it is going to compute the insulin from the insulin dose, that is nothing but the insulin reservoir is there, that time it is going to take it. And some of the for the few of the patients, for every 4 hours or every 5 hours they require the 4 ml of insulin. So for that purpose they are taking the log dose, and again it is going to work according to that. Every 4 hours it is working repeatedly. Next, for initially once we require the morning 4 ml of that insulin, so insulin dose will be taken from the insulin reservoir. Next, it is compute the pump command. The command is that for the 10 am you have to inject 4 ml of insulin. Next, the same data will be sent to the pump data, that is nothing but the actual pump is going to activate. Next, the control insulin pump, the pump is going to control very slowly 4 ml of insulin is injected to the insulin pump, and from the insulin pump to the patient body. Okay, so this is the activity model for the insulin pump. Okay, and next important thing is that this is totally automatic. We have to set what we are going to take, just we have to set the system, and automatically the sensors are going to recognize, and next according to that the pump is going to inject the how much ml of insulin is required. Fine. Okay, essential high level requirements. So we required the insulin when that is nothing but the system shall have available to deliver the insulin. Next, insulin reservoir is important. The system shall reliable and deliver the correct amount of insulin, so this is very much important. If a patient need only 4 ml, so that it should provide only 4 ml itself, not more than that or not less than that. And the system must therefore design and implement, ensure the system meets these requirements. So this is all about the insulin pump. Okay, next about the MainCare, a patient information system for mental health care. I will give this as a assignment for you people. You go through these slides, you will get to know that it is very easy. Just simply I like to explain this diagram. Okay, there are a number of patients are there, the database is stored in the patient database. Okay, in the future you are going to study the DBMS, that time you will get to know what will be the exact data. And one of the server is there, and that is server is connected to the network, and next according to that patient healthcare is going to be monitored. So you go through this, you will get to know that. Very in simple, in short I like to explain this system is that maintaining and managing the patient's things, that is nothing but the hospital management system. Instead of hospital, we are going for only patient management system. Next, some of the key features are there. Next, I am going for the weather information. This is very interesting thing, and this is very huge. I like to explain the things. Okay, nowadays you people are going through the lovely weathers. So if we check in Google, what will be the weather of tomorrow? Okay, that time you will going to get it. But this data is how they are going to give the continuous process is there throughout the year. They are going to take the details. Who is going to take the details. So in all over the world, some of the systems have they implemented, some of the sensors are there. The work of the sensor is to collect the data, and from the data, once the data have collected, they have to send to the local remote server or remote place, and from there it is going to the workstation. So here the station maintenance is there, weather station is there, data management and archive is there. So in short, I like to tell you people is that throughout the data, whatever the information is coming from all across the globe, that is taken. Next, based upon that data, it is going to do the processing. Okay, data processing will be the another important. Some of the standard architecture models are there, some of the algorithms are there, some of the softwares are there. Those are working continuously on that data, and based upon that data they're predicting it. Okay, so today's date is 18, probably from 19 to 20 there should be no error. This is just a prediction, not accurate. So this is nothing but the it is the architecture model. And for this architecture model, what we require first is require the data. That data is collected from the sensor. Next we require some of the processing algorithms or softwares, and once we get the software, and next we can produce the a result. Okay, so to understand this, basically I like to use a small example. If you people are cleared your first sem exam and second sem exam with 75%, so based upon your previous data, I can assume that yes, roll number 001 has cleared first sem and second sem without any backlogs. The overall percentage is 70%. So I can easily say that in third semester, if you maintain the same study, whatever he like to use, he can easily going to score 60 to 62%, not more than that, because you people are in a branch, some of the subjects are going to occur here, and the system is totally going to change it. Okay, next important is that in the first year, in the second year, you are maintaining the 60-65. So I can say that in the final year you are going to score 70-75 marks. So this is nothing but the based upon the assumption. The same thing here it is going to work. Okay, so here we are going to finish the first chapter, and regarding about the in interaction class we are going to discuss in detail about these all points. Thank you.